In this video, we'll talk about piezoelectric devices. So the main principle that governs the operation of these piezoelectric devices is called the piezoelectric effect. So piezo technically means press or squeeze in Greek. So what this does is, like, when you try to squeeze this sensor, so typically like we use a quartz crystal or some crystals like that. So what happens is when you squeeze them, like, it generates potential across the other sides actually. So that's what happens in a piezoelectric device, which is typically a crystal. And piezoelectric effect is the ability of those materials which can generate an electric charge in response to the mechanical stress and vice versa. And the opposite is true as well. Like, that's what the other side, like, where, like, if you apply a voltage across these devices, then it starts to vibrate, and that's how it oscillates. So for example, microphone and loudspeaker. So the microphone converts mechanical vibrations into electrical energy, and then in a loudspeaker the electrical energy converts that into mechanical vibrations. So that's what happens in a piezoelectric device. So here there are two types of buzzers. Like, say we do have both of these buzzers in your kit. So one is called the active buzzer and the second one is called the passive buzzer. So the active buzzer includes an oscillator. So oscillator is a circuit that provides the vibration to the device, and then, like, say you just have to apply some voltage across that, so then, like, it starts vibrating and then it produces a sound. And we have an active buzzer as well in your kit, and we also have a passive buzzer, so for which you will have to provide the oscillating frequency voltage, so that, like, it just vibrates based on that. You get to control at what pitch, or like what pitch the sound is produced by changing the frequency of the applied voltage. So we can also do that. So here, like, we have the code, and like this is how we are going to build our circuit. Although I have a resistor, it is advisable to have a resistor in here, but, like, you know what, like, the voltage is not too high. I'm not going to bother putting a resistor here, so I'm going to just use an active and, like, a passive buzzer, and then, like, connect it actually. So let's go and see its execution. So here is the active and passive buzzer. So you would have a small Ziploc baggie in the kit, and the kit should include something like this. So if you see, I'm not sure, let's see if it focuses. Okay, so it has something like HYDZ, something like that written, and, like, probably, like, when you haven't used it, like, when it is put in the package, it has a white, I couldn't find that from the kit, but, like, it would have a white label on the top, but the normal ones, like, which is not an active buzzer, would not have that. Like, it'll just have an indication of which one is the positive, but here in the active buzzer, like, you will have something written on it. And one more thing is, this one will have the oscillator circuit in this, so the bottom is kind of capped. But if you see the passive buzzer, it will not be capped. So the one without the bottom cap is the passive buzzer, and this is the active buzzer. For this buzzer, you just have to apply in voltage, and then, like, that will produce a sound. But again, like, that will work in a fixed frequency. So connecting to this is, like, sometimes a challenge, so you will have to know exactly where the pin is. Okay, let me put it here so that, like, I understand. Okay, so this is, I'm connecting it to 0 and pin 0, 1, 2, 0 and 2. So that's easier. So let me connect. So here there's an indication which pin is positive. So 0 is positive. So I'll have to connect 0 to the positive, and then this one to negative. So 0, 1, 2. Yeah. And I will connect it to the ground, and then the positive should be connected to 5 volts or 3.3 volts. Yeah. So if you see, this is 3.3 volts. 5 volts is like a little louder. So that's what happens when you connect a resistor. So the resistor will drop some voltage, so less voltage is applied to the buzzer. So if you use it if you plan to use it for a long time for something, for an alert system or something like that, I would advise you to connect a resistor. If you're using just like that, that's okay. Just for a while, it's okay. It'll, if you overload it, or like if you run it for a long time, then it tends to heat up. So that is the active buzzer, but the passive buzzer like doesn't work that way. So we'll have to provide an what to say? Maybe I will rotate it so that 0 and 1, 0, 1, 2 is connected. So this is my negative, and this is my positive. So I have made the connection. So right now what we'll have to do is we'll have to run the program which will generate the frequency at which like this could vibrate. Okay, so let me go back, and I'm going to bring in the Arduino. So let me stretch that. Oh, you don't see that screen actually, so just give me a second. Arduino. Okay, so here's the screen. Oh, sorry, and again, maybe you can see both. Let's see. Okay, so this is the one. Like I'm going to program this. I'll just like click and drag. Kind of stretch that out a little bit. Okay, so I'm going to connect this. Maybe let's do pin 2 here. The positive. Oh, no, the positive should be connected to pin 2. I'm connecting the other end to the ground. The positive is connected to pin 2, and I'm going to set that up here. So first, pin mode. Pin mode, and 2 is the pin, and it is output, and that is it. And I have to use, again, like there are functions, built-in functions for this. So this is called the tone function. You can write a pin, like write a program to oscillate, like, but we'll use a like built-in program called tone. So you don't have to install any libraries or something like that for this. So pin 2, have to indicate like which pin is that, and then like say at what frequency we'll have to vibrate that. So let's do 8000 Hertz. So, and I will delay for maybe 1000. Oh, that, and then probably you can also use the no tone function to not produce any tone, so you can stop that, and then we'll delay that for another 1000 milliseconds. So this one starts, delays for a second, and then like it no tone, and then delays, and again it starts. So this is what happens. So let me compile the program. It asked me to save it, so I'm saving it on the other display. So let me upload it. Compiling, done compiling, but like it's not. Just upload, come on. Oh, error occurred. What happened? Access denied. That is weird. Okay, so I have like multiple Arduino IDEs like open here. So yeah, if you see here, I'm not sure which one is which. The previous program. This is. I will get rid of that. This one as well. No. So if you have multiple IDs open, like something like that could happen. So let's upload. Yeah, uploading complete. Okay, so this is weird. So now we'll have to just make sure the connection is right. We'll put that 0 and yeah. Okay. Oh, timeout communicating with the programmer. That was another issue. I didn't notice that. This is weird. Actually, just taking. It's not uploading. Okay, let me disconnect the board, and then I'm going to just like copy this, copy, then close this, and then reopen. Like sometimes that happens. I just want to make sure all the Arduino IDEs are done. Okay, so I've just opened it, and let me connect the board, and then make sure. Okay, the board is not Arduino Mega. Oh no. And COM port 5. Yeah, now that makes sense. Oh wait, yeah, hold on. Yeah. So I think that was the problem. Maybe like when I opened up, so some other default board was selected. Compiling, uploading, done uploading. Yes, this is what I was expecting. So this is how, again, I'm going to keep all these. I'm not going to edit this out, so you can see like how we troubleshoot as well. So if something is not working, there are like series of things you will have to do. So first make sure like the communication is okay, and then like check the connections and all those things. You do one after the other, and like say getting rid of all the errors. And yeah, so this is it, and like let's generate like some other tone, like maybe 2000 Hertz. Let's see how that is. I know it's going to be a bit annoying, but let's try that. Oh no, sorry about that. That's 2000 Hertz. Okay, I've heard that, let's see, I'm not sure like how much we can, I think it can generate up to like 10,000 Hertz or something. Let's see how high of a pitch it can. After that, like you can, and I'm not sure if you've been to the Discovery Center in Halifax. There you will see that like you can't hear over like 14,000 Hertz or something like that. Technically, I believe like when we are younger, like we can hear up to 20 kilohertz. But as we get older, like we can only hear like around like say 15, 14 kilohertz and things like that. High frequency sounds like we'll not be able to hear. So it seems like I can do that. Oh no, I've changed something else instead. Okay, so 1000 instead of like, let's try 10,000, like whether we'll be able to produce that here. Sometimes it just vibrates if it couldn't. Yeah, it is still doing it. It is producing it. I'm not sure, like let me go up to 14. But like already I could feel the vibration instead. It's higher, but like it's still it's vibrating. I could hear the vibration, but I wouldn't say it is producing a quality 14 kilohertz output sound wave actually. So that is it. And yes, so we have an assignment for this question as well. So here you will have to write a code to activate two things: activate active and passive buzzer at 1,000 kilohertz. Oh no, that is a mistake. So that is not 1,000 kilohertz. Sorry about that. That is 1,000 hertz. That's 1 kilohertz wave. We'll just fix that. And then at 2 hertz frequency. So what is 2 hertz? So hertz is cycles per second. So twice every second. So you have to produce that. And you will have to add the code. You can add a screenshot or like copy paste, that is okay. And then you will have to attach a photo or video of this execution in Arduino now. So that'll be your assignment, and the next module will be on RGB LED, so it's already up there. So we'll meet in the next video. See you there.